Today on QDL, integrating your engineer-to-order process with your ERP. That when we come back. Welcome back to QDL. QDL is your look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. So most of you are familiar with ERP systems, and many ERP systems today are still tailored, really designed to support a made-to-order manufacturing model, repetitive manufacturing. The manufacturer has a standard product, maybe with some options that a customer can order. They order the parts, it gets entered into the system, and the ERP helps track everything related to that order and its production. That's repetitive manufacturing, kind of what ERP has been for 40 years. However, because of advancements in engineering tools and processes, more sophisticated and faster CAD software, additive manufacturing, robotics and so forth, AI, we have seen a substantial growth in engineer-to-order manufacturing. ETO used to be expensive and done only when necessary. Engineering to order now is becoming more commonplace because it's something that is easier to do, less expensive to do. So why not order exactly what you want, right? And so if you're not familiar with engineering to order, this is where customers, rather than having to depend on standard products with available options, they simply ask for exactly what they want, and the manufacturer engineers those products to order specifically for them. Now, this can present a bit of a problem for legacy or old ERP systems, which have always been somewhat separated from the engineering design function. And this has created a set of headaches that are kind of unique to engineering to order manufacturing organizations. So today we have with us Andrew Schutte, General Manager at Smooth Logix, developers of COUNTERPART ETO ERP. Hello, Andrew. Thanks for joining us.
Thanks for having me.
Sure. And did I get your last name right, Schutte?
It's pronounced several different ways. We would commonly do Scuddy, but I answer to everything.
Okay. Well, it's like my last name. People don't even attempt.
I wasn't even going to attempt that.
Okay. So talk a little bit about engineer-to-order companies and how do they differ from made-to-order companies? Kind of what are their unique challenges?
Yeah, so I think to set the stage, we've got the traditional configured option that consumers would be commonly aware of. So if you consider buying a new vehicle, Ford Motor Company will not engineer to order for you an F-150, but if you count all the trim options and color options and cloth or vinyl or leather interiors, you can get, somewhere in the order of 100,000 unique F-150 configurations. And so that's kind of a middle ground between Henry Ford's, you can have whatever Model T you want as long as it's black type mass manufacturing, to the common consumer configured or customized manufacturing where I can get an F-150 in the color I want, which is kind of in the middle ground to engineer to order, where you go to a custom, let's say, cabinetry maker for your home and say, I want a cabinet that is 28.5 inches. And it's not a standard, it's not a configured option. Nobody's ever done that before, but I want this specific cabinet, this specific size. And in the carpentry industry, for example, there's good enough software, as you mentioned in the intro, the automatic aids that the CAD engineering software world have provided. Cabinet makers today can easily scale and change and modify the widths and heights and sizes of their cabinets, along with the doors and the drawers and everything else to give the customer, basically for no extra cost, depends on how the company is set up, that special width cabinet. The cabinet example is fairly straightforward. I think pretty much everybody understands the specific challenges and the specific software solutions for that. Where COUNTERPART really fits in, and where our customers have seen the largest value, is in the custom machine and automation industry. So one of our customers, several of our customers actually, are in the food and product and beverage industry. And if you ever go to a grocery store, it's amazing to me how many different sizes and types of bottles and liquids and products there are in the consumer purchased available for consumers to purchase in a Meijer or a Walmart or a Kroger or whatever you have in your area. And every single time a new bottle is designed with potentially an old or a new fluid, right? We've always got new fluids, whether it's kombucha or these different trends that come out, but there's always these different unique bottles. And somebody somewhere is designing a bottle and a fluid to match, and then somebody else is designing typically a machine to put the liquid in that bottle. Now those machines are extraordinarily complex, 60 to 80,000 components. They'll fill bottles anywhere from hundreds to up to 1,000 or 1,200 a minute. And that's engineer to order, right? There isn't a machine out in the universe that's gonna put kombucha in a brand new glass bottle or plastic bottle. So somebody has to use their engineering expertise to accomplish that challenge. And then that consumer product gets out into the shelves of your grocery store at some point, and consumers are really happy to have a new type of drink that they can enjoy,
right?
Without really understanding, in my experience, without really understanding all of the complexity in the background that brought that product to market, which is really exciting for us.
Right. So your company makes a product called COUNTERPART, which I understand that it's an ERP solution, but I guess what's unique to it is that it's integrated with SolidWorks, which, if our viewers aren't familiar with, is a CAD package. How does this address the issues that you were just talking about?
Here's a very common scenario. I'm given an automotive part that isn't yet released to market, right? It's a brand new interior console or door handle or review mirror for a new model production automobile that isn't yet released. So it's a part I have never seen before in my life. We're given the instruction, we need to assemble it, put in the pin, put in the spring, crimp the pin, snap in this keypad, install this glass, put in this electronic, whatever it might be. And we need to build one of these every 5 seconds or one of these every 10 seconds. Office furniture was a little bit more lax. We only had to build things about, one every minute, which was the world in the world of automation as far as time goes. So you go to SolidWorks and you start designing and you say, okay, here's my frame, here's my base, here's my tooling, here's my nest, here's my fixture, here's my robot, automation, whatever it might be. And inevitably, at some point, there's never enough time. Everything's always pressed. The customer wants a design review. The shop needs something to do. And there's a point in time where the owner or the boss or the design manager comes along and says, Andrew, that frame, is it done? Is it ready to go? Is it big enough? The shop floor needs something to do. Or to meet our deadline, to meet our timeline, we have to start manufacturing the frame today, so that we can buy the steel, get it welded, get it machined, get it painted, whatever it might be. And we need to start machining these 3D nests. And so I have a half-done design that's not even yet approved from the customer, still continuing to finalize the details of the automation that's going to be used to put these components together. And my boss is asking me to release components to the shop floor to meet deadline. And this is just the reality of an automation machine builder. We've never built this machine before in our life, and we have to do it rather quickly to meet deadline. So having an ERP solution directly integrated into SolidWorks is extremely helpful, because from inside of SolidWorks, I can say, COUNTERPART as our ERP solution, I want to release this frame, send this frame to manufacturing and get it built, and send this tooling and this robot, right? This ABB or Funnock or Motorman or Epson or robot that I'm using on this machine, or several robots. They're 8, 10, 12-week lead time. So get the robots ordered, get the robot controllers ordered, get some of maybe this hard tooling that might take 10 or 12 days to manufacture. Start making all of these bits and pieces of a machine that I've never designed in my life, will never make again, to make a part I've never seen before that isn't yet designer approved or finalized from the customer. And without an ERP solution that integrates to SolidWorks, the specific challenge, and I live this firsthand myself, is you end up with a dozen or 2 dozen or 3 dozen Excel spreadsheets, various bills of material, various components at various revisions with various quantities ordered from various places and states and people. And hopefully, as a designer, you're well organized, because at the end of the day, the boss expects all of the right parts of all the right revisions to show up on the shop floor at the right time, so the assemblers can assemble and build the machine correctly. And you can't have any parts missing. You can't have any parts not there. You can't have any extra or any few. And along the way, revisions got made, customer changed their mind, parts changed, right? The part grew by 1/2 of an inch because there was a wind issue in the review mirror, so the automotive designers changed the part itself, and you have to adapt those changes on the fly.
It sounds like what you're saying is that you're communicating during the design phase in SolidWorks. You're communicating parts that are ready to go, released, and equipment that's going to be used and so forth. You're getting that into the funnel quicker? Is that really kind of what's going on, without having to do extra paperwork and release an entire package of documentation? It's just kind of, it's integrated with the entire system.
Yeah, I mean, in the old days when timelines were, we'll say kinder, we had more time to do things in the olden days. You would iteratively go through the design, get the design approved by the customer, and then tell your purchasing and manufacturing, here's the 3 or 5 or 10,000 components that we need. Make and buy these things. When they show up, we'll put the machine together. But as timelines have condensed, designers are required to kick off and start some of the manufacturing processes of some of the components, buying some of the purchase components, making some of the manufacturing components before the design is even done. So it's like, starting to build the engine for a truck that isn't yet designed, and there's a chance the engine's not going to fit by the time the truck's done being designed. But you have to start building it to get it done on time.
It sounds like it's just, for the engineer, it's faster, and also I would imagine less prone to error as you're constantly going back and revising documents, and if you're going, I used to be a designer myself, so I know, but this was back in the paper days, is that,
right.
Literally you'd have to generate a flurry of paperwork, you'd have to take it over to the drafting department would draft up the changes, and then that would be communicated to the purchasing department and so forth. It sounds like that this just kind of streamlines that whole process, eliminates duplication, and I would imagine kind of minimizes just errors, transcription errors, duplications, that sort of thing.
But think about it this way: in a true engineer-to-order environment, the singular person that knows what's necessary for that particular project to fulfill the particular customer's request or order is the engineer. There's no other method to determine what needs to be manufactured without the engineer's direct input. And so a SolidWorks integrated ERP solution allows the engineer directly through the SolidWorks interface to say, I, the engineer, designed this. This is what's necessary to accomplish this particular project. So let's go get it on order. Let's get it manufactured. Let's pull it from inventory. Let's get this done, without ever having to type an email, print something off, push paper, go talk to anybody else. So it's a very integrated solution. In your batch manufacturing, mass production type concept, the toothbrush you buy from your local grocery store, that we're just going to make 10,000 of them every week or every month and ship them out to our distributors. And if the customer wants to buy it, they can buy it. That doesn't really require engineering input, and there's no necessity for a CAD interface. And that's really the uniqueness of Counterpart, is engineers can do their engineering and collaborate with other engineers. For example, one of our customers has 30 mechanical engineers, and they commonly, the average size of their machines are about 60 to 80,000 components. So imagine 30 engineers collaborating, and at the end of the day, 60 to 80,000 components of various quantities, various revisions, and various assemblies need to be procured, assembled, put together, and run and be successful, and then ship that machine. Historically, that would be managed by humans with paper, with spreadsheets, and with manual data management. And today we can do it with an integrated ERP solution.
Kind of the elevator speech here is what is, if you could just really briefly, what is the benefit for the engineer? What's the engineer get out of this? And what does the company get out of this?
Yeah, so I mean, the easiest way to answer that is just basically give you what our customers have told us, or the testimonials, right? You can find it on our YouTube and other places, but on average, the engineering department that's using Counterpart in this environment, we see is 15 on the low end up to 20 or 25% more efficient. So if you have 10 engineers, and the business is growing, you can adopt Counterpart and grow the business by 20, 25% without hiring another engineer. So that's monumental from an efficiency standpoint. And then from a business owner standpoint, it all comes down to revenue, making money, staying competitive, and being able to get the most out of your organization without having to hire or grow and expand. And using the Counterpart ERP SolidWorks integrated solution, we also have a very high 90th, so 98, 99 percentile of accuracy from the SolidWorks bill of material integrated through Counterpart to manufacture. So without Counterpart, all of our customers would have some degree of unordered parts that they had to then expedite at the last minute, or duplicate ordered parts which they had to throw away. And those savings range based on the quantity and the cost of those parts. But we have some customers that say they're saving $50,000 a year on just expediting fees and throwing away perfectly good parts they didn't need, because of the increased accuracy and ease and efficiency in which they're able to communicate between the engineering department, the purchasing, manufacturing, inventory, and assembly departments.
Andrew Schutte, General Manager at Smooth Logics, developers of Counterpart ETO ERP. Thanks for joining us today. Appreciate it.
Yeah, thanks for having me.
No problem. And that's our show for today. As usual, if there is someone you would like to see on the show or some topic you would like us to cover, let us know. Send your ideas to us at qdl@qualitydigest.com, and we will try to get those onto the show, those people or those topics. Thanks for joining us, and we will see you at the next QDL. So long.